Hello dear students, all of you, good afternoon. Right, hope all are doing well. I think for the preparation of JEE Advance. Right, in the last class we discussed permutations, combinations related special subtopics like number of ways of dividing as well as distributing the items into boxes. Right, we have seen all the cases like similar items into dissimilar boxes, similar items into similar boxes, similarly dissimilar items into different kinds of boxes. Fine. Now in this class, in continuation to that, we are going to see a wonderful set of problems, all the models at one place related to integral solutions of certain equations, especially linked with permutations and combination related one, right. So shall we move into the topic? Ready? Chalo. Friends, by the way, this is BS at faculty for IIT JEE for the new students who are attending the class for the first time, right friends. Now you see dear student, this question, in this class flow we will see number of integral solutions related content. Okay. You see, we require only 2 points here. One is, you see this result, number of non-negative integral solutions of the equation x1 plus x2 plus x3 plus and so on xr is equal to n is just like number of ways of distributing n identical balls into r boxes, right. So which is nothing but, you see the formula is n plus r minus 1 c r minus 1. You see friends, this formula is going to play a vital role in this particular topic. You see, the number of non-negative integral solutions of the equation, you see there are r boxes x1, x2, xr are dissimilar boxes and n identical balls are kept into this. So number of non-negative integral solutions is n plus r minus 1 c r minus 1. So why so? We've seen in the last video, you can please go through it, right. The next friends, the number of positive integral solutions. What is the difference between the previous point and this? Here non-negative integral solution in the sense each variable can take integer solutions, of course it can take 0 or positive. That means for example you are given an equation like x plus y plus z is equal to 8. Here x0, y0, z8 is also a solution, x0, y7, z1 is also a solution. Whereas if you are talking about number of positive integral solutions, if you take the equation x plus y plus 8 is z is equal to 8, here friends 0, 0, 8 solution is not admissible because we want positive integral solution. So x must be a natural number, y, z also greater than or equal to 1. So 1, 1, 6 is okay, 2, 3, 3 is okay, like that. So that is the difference. So friends, if you want number of positive integral solutions of the equation, you just see here x1 plus x2 plus x3 plus and so on xr is equal to n is friends n minus 1 c r minus 1, n minus 1 c r minus 1. Friends, here this is equivalent to number of ways of distributing n identical objects into r boxes such that no box is empty, because if this means x box is empty, y is empty, z took all the 8 identical balls. This is not admissible here. So point number 2 is n minus 1 c r minus 1 is the answer for number of positive integral solutions. Clear friends? With the help of only these 2 points, and here and there if I require, I take the help of multinomial theorem application, These 3 points are enough to answer all the kinds of this question, right. Synopsis wise only 2 points. Let me repeat, the number of non-negative integral solutions is n plus r minus 1 c r minus 1, this formula, and number of positive integral solutions wise n minus 1 c r minus 1, only 2 formulae in this stage. Okay. Now, let us move to problem number 1. You see the question, friends, number of non-negative integral solutions of, what is the equation, friends? X plus y plus z is equal to 10. So, now we have a direct formula. Here n is nothing but 10, 3 dissimilar boxes r is equal to 3. He is asking non-negative integral solutions. What is the formula? N plus r minus 1 c r minus 1, right. So, friends, it is going to be 13 minus 1 12 c 2. You just compute, you will get the answer. 12 c 2 is nothing but 12 into 11 by 2, which is going to be 66 is the answer. Simplification part you can do, it is not a big thing. So, it is a direct question, basic question without any constraints, right. Clear. I think you can do this problem easily. Now, friends, you see this question, the number of, yes, see the question, positive integral solutions. It is not non-negative, be careful with the thing whether he is asking non-negative or positive. The equation is also of the same kind, x plus y plus z is equal to 12. Okay. Positive integral solutions in the sense, already we have a formula n minus 1 c r minus 1. So, mechanically you can substitute in the formula. You see here n is going to be 12 and r is going to be 3, number of variables or number of boxes. N minus 1 is 11, r minus 1 is 2, 11 c 2, which is going to be 55. Am I correct? Fine. So, 2 questions are very fundamental, we have done easily, right. Now, you see this question, the number of non-negative integer solutions of this equation. You see, what is the equation given here? X plus y plus z plus 5t is equal to 15. Here it is not t. If it is just t, I would have written directly, but 5t is given. Some multiple of variable is given, but nothing to worry. You do one thing, t can be, he is asking non-negative integral solutions, so any variable can take 0, 1, 2, 3, 4. Better you give cases for this, put t is equal to 0. In that case, the equation becomes x plus y plus z is equal to 15. Now, that means when you are writing the triplet like 4 tuples x, y, z, t, t is going to take 0 and you just see how many x, y, z will come. This is number of non-negative integral solutions. Apply formula number 1, n plus r minus 1 c r minus 1, that is all. Now, second case, when t is equal to 1, dear students, this becomes x plus y plus z is equal to 10, because already 5 is gone. So, in this case it is going to be 12 C2 cases, n plus r minus 1 c r minus 1. When t is equal to 2, you can see now already 10 is gone. So, x plus y plus z is equal to 5. That means number of cases is going to be 7C2 here, right. Fine. The last case, if you take t is equal to 3, so you are going to get x plus y plus z is equal to 0. Of course, it will give only one case, which is 1, because x0, y0, z0. That is all. So, the total number of cases can be taken like 17C2, plus 12C2 plus 7C2 plus 1, that is all. So, if you are given any multiple of some variable, better you give cases, right dear students, clear. So, shall we move to the next problem, right? Fine. Next, you see this question. What is given here? Number of non-negative integral solutions of, you see, given first variable plus second variable plus third variable plus fourth variable is less than or equal to 20. And if it is equation equal to 20, we have a formula. Less than or equal to 20 means how to do? Generally student will give idea, array yaar, what is there? It is very simple. You write solution for is equal to 20. That is equal to 20 means 23C3 you are going to get, because n plus r minus c, n plus r minus 1, cr minus 1. Then this is the solution for is equal to 20, right? x1 plus x2 plus x3 plus x4 is equal to 20. Now you try it for 19, you will get like 22 C3, you write for 18, that is 21 C3, like that you write up to 0, you add all these things, that is fine, you will get. But rather, is there any short method, easy method to answer this question? Can I expect from the students who are watching the thing? I can see I can see the chart box, I can give the solution here. Fine, right. So friends, let me give you a small technique here to do the problem, to close the problem in few seconds, right? You see, yeah, instead of x1 plus x2 plus x3 plus x4 less than or equal to 20, you write equal to 20, you introduce x5. That means friends, if you just find number of solutions for this non-negative integral solutions, it is enough. Why? That means friends, when xy is 0, this is 20, first equation solution. When x5 is 1, this is equal to 19, second set. You see all the cases you will be getting, right? So, if at all you are given like less than or equal to 20, better you introduce a new variable, dummy variable, so that this becomes equation. So, you just write number of non-negative integral solutions, n plus r minus 1 cr minus 1, which is going to be 24C4 is going to be the answer. That is all, close. So, this problem, just this small idea helps you a lot to close the problem in almost 1 second, right dear students? Okay, hope you are following well, right. Next you see this question friends, of course the same kind of, the number of non-negative integral solutions of the same kind of less than or equal to n is given instead of 20 in the previous problem. So, you can write like x1 plus x2 plus x3 plus x4 less than or equal to n. What logic will you apply? Plus x5 is equal to n. So, now you just find the number of non-negative integral solutions, n plus 5 minus 1 c5 minus 1. Am I correct? So, which is n plus 4 c4 is going to be the answer. This is the answer friends, clear, right? So, simple here, just you understand the technique, it is very simple to identify the answer. These questions are very easy and important even, right dear students. Now, you see this question, the number of integral solutions to the system of equations, okay, he is asking about integral solutions, but he said each k, xk is greater than or equal to 0. So, non-negative integral solutions such that x1 to x5 the sum must be 20 and x1 to x2 the sum must be 15. Two conditions are there. Fine, you just write number of non-negative integral solutions for this. In how many ways can you write x1 to x2 15? You can also write 0, 15, 1, 14, 2, 13, 15, 0. 15 solutions, 16 solution will come, or else you can also write n plus r minus 1 cr minus 1, which is 16 c1, which is 16. This you can say directly also, 0, 15, 1, 14, 2, 13, like that you can also write 15, 0, 16 solutions will come. Once this is done friends, x1 plus x2 is 15, the second equation becomes x3 plus x4 plus x5 is going to be 5. Now you just write number of integral solutions. You see friends, this is 5 means n plus r, 3 variables minus 1 cr minus 1, which is going to be friends 7c2. What is 7c2? 21. So friends, you see, in each combination, whenever suppose you have taken 0, 15 here 21 cases will be there. If you take 1, 14, 21 cases will be there. Total number of cases are going to be, there are two fundamental works, first work into second work, 16 into 21 is going to be the answer, right. So this is going to be multiple of 3, this is not multiple of 3, it is multiple of 6. So last digit is 6, this is the answer, right. Simple friends, two conditions simultaneously, find the solutions for this as well as this. Now the total number of possibilities, for each possibility of this you will get 21 here, there are 16 possibilities, 16 into 21, clear friends, right, good. The next, you see the next problem, yeah, the number of positive integral pairs xy such that 1 by x plus 1 by y is 1 by 2007, right, and of course x less than y, fine, okay. So friends, you can simplify that equation like, you see, x plus y by xy is equal to 1 by 2007. So you can write x plus y into 2007 is equal to xy. You can just write like friends, xy minus 2007x minus 2007y is equal to 0. Now what I do is to write like a product, x minus 2007 into x minus 2007 is equal to 2007 square. Am I correct? You see, product, because I have added 2007 square on both sides. Arey yaar, 2007 is a multiple of 9. Try to do prime factorization. 9 into, you see, 2, 2, 3. Yes? Yeah. Whereas 223 is a prime number. So no further factors. So friend, this is like a into b is equal to, its square means 3 power 4 into 223 square, that is the thing. Now whenever you get some value for this, maybe 1 or 2, x is going to be 2007 plus that, you see friends, in that case you can comfortably find the solutions for this, right. So I mean to say x, you can write here y. So you try to give positive integers friends, 3 power 4 or 3 identical 4s can be distributed, can be given to a. In how many ways it can be given friends? So 4 things are to be distributed into 2 groups, 4 plus 2 minus 1, that is 5 c1, 5 ways. That means no 3 here, all 3's here, like 1 3, 3 3's here, like that, 4 cases. And 223 square, 2 identical things are to be distributed into this. So 2 plus 2 minus 1, 3c1, so you can say 3 ways. So 5 into 3, 15 ways you are going to get x value as well as y value to be 2007 plus something, fine. So friends, here in these 15 cases, you see, since it is perfect square, you see x and y equal case will be one case. So, 14, half of them will be there where x less than y, half of them will be there where x greater than y. So, this problem can be answered in this way, right dear students? Fine. Next, you see this question, find the number of positive integral solutions of x1, x2, x3, x4 is 770. You see, product of 4 variables x1 into x2 into x3 into x4 is 770. I think you can write 7 into 11 into 2 into 5, all are prime. Now friends, you see, you have to distribute these 4 prime numbers into 4 boxes. Suppose if all the 4 are kept in one place, 1 1 1 770 is the thing. Suppose you kept 7 here, 11 into 2 here and 5 here, that means here it is 1, 7, 22, 1, 5, like that. So, the number of distinct integral solutions, positive integral solutions, is nothing but number of ways of distributing these 4 into 4 decimal boxes. All are different. 7 can be kept in any of the 4 boxes 4 ways, whereas 11 also into 4 boxes, 2 also, 5 also, which is going to be 4 power 4, which is 2 power 8, that is 256 is going to be the answer, right? See, this is one kind of question. You see the model questions, friends. So, we can see variety of questions here, right? Now, I think you can answer this question like x plus y plus z plus 2w is 20. So, you can put w 0, 1, 2, 3 and so on. As well, you can also do by using multinomial theorem, like friends, you see, we want is equal to 20, x power 20 coefficient in the expansion of x can be taken like 1 x, x square and so on, infinite you can take because there is no upper limit. Similarly, for y also you can take an expression like 1 plus x square plus and so on, infinite. In for z also 1 plus x square plus and so on, infinite. For 2w in the sense, there we will be getting only 2's. So, 1 plus x square plus x power 4 plus x power 6 and so on, infinite. In this product you can collect the coefficient of x power 20, friends. So, you see, this is by GP 1 by 1 minus x, such 3 terms are there, into here also 1 by 1 minus x square, right. In this you need to catch the coefficient of x power 20. So, you can write, friends, 1 minus x whole power minus 3 into 1 minus x square power minus 1. I think you can try to find the coefficients like this. In this you can find, I think here the logic that is going to be helpful, 1 minus x power minus n, in this x power r coefficient is nothing but, friends, there is a shortcut, n plus r minus 1 CR. This is the third formula that is helpful in these problems. In the expansion of 1 minus x whole power minus n, x power r coefficient is going to be yes n plus r minus 1 CR. Okay. So, here of course cases will be there, here constant term into here x power 20 coefficient, here x coefficient into x power 19 will not be there, only even will be there. So, x square into x power 18, like that you can try, or else our regular method w is 0, w is equal to 1, w is equal to 2, those cases also will work out, right friends, fine. Next, friends, you see this kind of question I have already told you, just introduce one more dummy variable plus t. So, you can deal this question with x plus y plus z plus w plus t is equal to 20. You can write this question. Now, you see, friend, this question, this is number of positive. As a summary I have written these questions, fine. This kind of questions where you will have limits for the variables. How to do this question, friends? Non-negative integral solutions of a plus b plus c is 12, a greater than or equal to 0, fine friends, and a b greater than or equal to 2, he said. Greater than or equal to 2 means this bag must contain minimum 2 balls, C also minimum 3 balls. You do one thing, you put 2 balls in this, 3 balls in this, 5 balls are done. So you can treat it like A plus nu B plus nu C, 5 balls are done, only 7 are left. Now you can just put these 7 identical balls into 3 boxes such that a box can receive any number of balls. So n plus r minus 1 c r minus 1, which is 9c2 is going to be the answer. Right friends, when lower limit is given for the variables, it is not a big deal, you can comfortably put those, or else you can also find like you want x power 12 coefficient in the expansion of here 1 plus x square and so on infinite terms into, for b greater than or equal to 2 means you can write x square plus x cube plus x power 4 plus, you can write in the third one x cube plus x power 4 plus x power 5 plus and so on you can write. So you can take x square x cube, so x power 7 coefficient you can catch in the rest of the things, that is 1 minus x power minus 3 will come. We have already shortcut to write. This is method 2 friends, but this is very simple, you can directly write. Okay, fine friends, if upper limit is given a plus b plus c is equal to 8, if upper limit is, you see, first of all, you see b should contain minimum 1 and c must contain minimum 3. First give 4 balls to them. Now it is like a plus nu b plus nu c is equal to 4 balls are done, now is equal to 4, whereas the rest of the balls it must contain already b minimum 1, 3, 4 are done, but b uppercase is less than or equal to, you see b means I have given b minus 1, you can change as so already 1 is there, you can give at least 1 here, and here also upper limit, here you see already 3 are given, so 7 more can be kept. When upper limits are there, so better you take multinomial 1 where you take, otherwise you can also take that x power 8 coefficient in, you see a greater than or equal to 0 means 1 plus x square and so on infinite, and b can be x plus x square only, b can be 1 or 2, and c can be, you see x cube plus x power 4 plus and so on x power 10. In this you try to catch x power 8 coefficient, already x cube and x power 4 will go out, so in you try to find x power 4 coefficient in 1 minus x into, you see 1 plus x into, this is going to be 1 plus x plus and so on x power 7. You just take the product and consider x power 4 coefficient, right friends. So in this way you can try these problems also. The rest of the problems we will do in the next class. You see friends, my point is in this class, if we bring all the models of integral solution problem at one place, generally students will have some comfort so that they can attempt the questions confidently. It helps you for the revision of this particular subtopic, right friends. So I think it is helpful to you. If you really like it, you can share as well, you can subscribe to our Infinity Learn, right dear students. Thank you.